Assalamu alaikum dear students. In the previous lectures I told you that when aniline is reacted with nitrous acid it is converted into the diazonium cation, and when the diazonium cation is treated with suitable reagents and slightly heated it evolves the stable nitrogen molecule, and the reagent or the other group like halogen, hydroxyl group or the cyano group or the thio group is placed on the ring. Today I am going to discuss about the mechanism and why we use the diazonium for some specific reactions. So why we use the diazonium? In organic reactions, if the number of steps increases, yield decreases. So diazonium is the easiest way to attain our desired products with limited steps. Other routes are lengthy and steps are increased, and due to purification and crystallization reasons the yield of the product decreases. And there is a possibility that some side products are also formed. If you want to form the metadibromobenzene, then the diazonium is helpful. I use for the formation of those products which require production using a directing group. So why we use the diazonium? The other reason is that some specific reactions like fluorination, it is highly exothermic reaction and explosive, and also there is the possibility of polyfluorinated products. So we use the aniline molecule and diazotize it at 0 to 5 degree centigrade temperature. Then benzene diazonium chloride is formed. When it is treated with HbF4, benzene diazonium fluoroborate is formed. When it is heated, it is converted into fluorobenzene and the stable nitrogen molecule is released. Now how we form the diazonium salt? Step 1. Preparation of the nitrous acid. Nitrous acid is usually generated by the acidification of aqueous solutions of the sodium nitrite with a mineral acid. The acidification is usually conducted at ice temperature and the nitrous acid is consumed in situ. Free nitrous acid is unstable and decomposes rapidly. The free nitrous acid decomposes into nitrogen dioxide, nitrous oxide and water. It is prepared in situ. It means that when there is need of nitrous acid, it is then prepared with by reacting with the aqueous solution of sodium nitrite with hydrochloric acid. Now we will see that how the nitrous acid is converted into the nitrosonium cation, that is the actual electrophile. In the presence of hydrochloric acid, sodium nitrite, the oxygen of the sodium nitrite gets protonated and converted into the nitrous acid. Nitrous acid further react with the hydrochloric acid, and the hydroxyl group present in the nitrous acid is protonated, and the oxygen becomes the good leaving group. There is the elimination of the water molecule, and with the resonance phenomena we get our the nitrosonium cation. Step 2. Mechanism of the formation of diazonium salt. Nitrogen atom in the aniline molecule donates its lone pair to the nitrogen atom in the nitrosonium cation. As a result, the pi bond between the nitrogen and oxygen atom is shifted toward the oxygen atom, which is which have full flag positive charge. In the second step, there is a resonance between the lone pair and the double bond with the nitrogen and oxygen. As a result, here proton transfer occur, and the proton on the nitrogen of the aniline molecule is shifted toward the oxygen atom. Now, oxygen in the third step, also another proton is transferred to the oxygen atom, and the lone pair is delocalized, and the oxygen atom is now become good living group. The lone pair of nitrogen is delocalized, and as a result, stable water molecule is released, and we get our final product, diazonium salt. Diazonium salts are fairly unstable and explosive, therefore usually not separated. Other reagents that we want to replace it with the group is added in the reaction mixture, and the final product is obtained. Now there are some application of the diazonium salt. In Gatterman reactions, diazonium groups are replaced with chlorine or bromine by treating them in the presence of copper powder with the halogen acid. Similarly, the diazo group is replaced by iodine by treating with potassium iodide. Actually, a direct iodination of benzene is not possible because it yields very poor. The yield of the reaction is very poor because the iodine is the byproduct formed is hydrogen iodide, which is a good reducing group, and it reduces the benzene iodobenzene to the benzene molecule, and the product yield is very low. If we use an oxidizing agent in the reaction mixture like nitric acid potassium iodate, then the oxidizing agent converts the hydrogen iodide into the iodine molecule, and then the yield of the product can be better. Similarly, there are various applications of the diazonium salts. As the dyes that are most widely used today are made through the reaction of an electron-rich aromatic partner with a diazonium salt. Only electron-rich diazonium aromatic species are good enough nucleophile to attack diazonium salt. As you see in the example, that the diazonium coupling reaction takes place with the methyl phenyl ether, and the resulting azo compound is obtained.